Right, okay. So here's where we stopped last week. We started to talk about solving quadratic equations. We started to talk about quadratic equations. The subtopic we had before that was quadratic functions. Now, let me remind you again, I want you to have a very thorough understanding about quadratic functions, okay? Because everything else that we do with quadratics is embedded in the quadratic function or related to the quadratic function. If I go back, if I go a little, if I show you the, right, quadratic functions, if I show you this, you know that any quadratic function, so in the form y or f of x is equal to ax squared plus bx plus c, when you graph that function, any quadratic function looks like this. And you have to understand what this graph shows you. It's showing you all the pairs of numbers that fit this relationship. When you put this value for x, what the whole quadratic gives you, the y value. So it's showing everything to you. So if I ask you the quadratic equations that you will be solving, it's kind of embedded here. It corresponds to a certain pair of points here, the pair where y is 0, right? Because in an equation, what you have is your quadratic expression is equal to 0. So that corresponding point is here in the function, right? So everything is here in the function because it shows everything. So please spend some time. Please spend some time to really understand what the quadratic function, like if you have it written in this form, it's just like the function equation. But when you graph it, everything becomes visible about the function. Okay, so please keep that in mind. And when you go to quadratic equations, right, I told you that if you look at the graph of the corresponding function here, I'm just reminding you last week's work. If we are to solve this equation, I have x squared minus x minus 6. That's my quadratic equation, is that being equal to 0, that is being set equal to 0. If I want to solve that, I'm trying to find what values of x would make this whole expression's value equal to 0, right? Then if I think of the corresponding function, y is equal to this, and if I graph it, I can find out from the graph where y is 0 and for what x value that happens. And graphically, that's...
Excuse me, miss?
Yes, Afra?
Your voice is lagging here.
My voice is lagging. Let me check the Wi-Fi. The Wi-Fi is fine. Is there a big, a considerable lag? How is my video thumbnail? Is that lagging too?
No, miss.
Okay, let's let me check this. It seemed to be okay.
Miss, I think it's some connection with Afra's computer. Because I think...
Hear me fine?
Yes, miss.
Afra, could you check your the Wi-Fi connection on your end? Now that's the thing, right? But I appreciate that. I appreciate you letting me know. I want you to let me know if there is anything, a lagging in the voice, a lagging in the video, a lagging in the screen, anything wrong, anything that's going on in the screen that I'm sharing with you. If there is something happening, I want you to let me know, because I might not see it. My screen might look to me fine, but also something like that could happen due to your connection problem as well. So can everyone else hear me and see me fine? if that's the case, then that it must be something on Afra's side. Okay, Afra, see, at the moment I ended sharing the screen, it's fine, right? Let me try that again. Let me go back to the screen, the note. Let's see again, okay? So I was talking about this. I said, when we want to solve this equation, how can we think about solving that equation if we have the corresponding graph of the corresponding function? So this is, here I have the graph of the function y equals x squared minus x minus 6. In simple words, the solutions to the equation are the x coordinates, the values of the x, where the parabola is cutting, intersecting the x-axis, because that's where the y coordinate is 0. Y coordinate is the value of the whole expression, right? So it becomes something very simple graphically. Solving the equation, I know that you know how to solve it algebraically, but if you happen to have the graph, it's just a matter of just looking at it and giving the answers if the two points can be read easily, right? Like in this case, -2 and 3. Right, so this is what we saw last week. And then I said, that would mean, now we know that when you have a quadratic graph, your graph, depending on the positioning of the graph on the grid, you can have upright and upside down parabolas, and depending on where on the grid it is, your parabola might be crossing the x-axis at distinct 2 points, or it can be just barely touching the x-axis, or it might not be touching or crossing the x-axis at all. What this could mean for solving an equation is that when you try to solve an equation, there might be cases where you get 2 proper distinct answers, 2 real number answers, or you can just get 1 answer. That means the corresponding function is only touching the x-axis at 1 point, or you could not get any real solutions. That means the corresponding parabola is, either it's going like that below the x-axis, or it's hovering above the x-axis, right? So this is what we discussed last week. And today we will now actually go and solve quadratic equations. And I said, I think that there are 3 algebraic methods of solving an equation. There is a graphical way, you already saw it. If you happen to have the graph, it's just a matter of looking at the graph and giving the solutions. So remember, any equation, not just quadratic, any equation can be solved graphically. If you have the corresponding graph, you can look at the graph and say what the solutions are. But usually we solve equations algebraically. You manipulate the terms, you throw them around, put them on this side, put them on that side, divide, multiply. You make algebraic manipulations to make x the subject. That's how you usually algebraically solve an equation. So same thing for quadratics. To algebraically solve, we have 3 methods to solve a quadratic equation. So let's go and look at these 3. And this has to do with, remember our forms, the different forms in which we can write a quadratic. So this first method is by factorizing, which you are already very familiar with. If your quadratic, in the quadratic equation, if the quadratic that you have in your equation can be factorized, you can factorize and solve it. So this is something that you know. Second method, that is by factorizing. Second method is you can use completing the square. If you complete the square, that enables you to make x the subject, just like in a normal equation. Okay, so we will look at that as a second method. And lastly, you can use, especially if you can't factorize your quadratic, you can use the quadratic formula. And that formula is derived from the completing square method. Okay, so it's just the same thing as completing the square. It's just it has done like that. When you use the formula, you are unknowingly doing the completing square process, right? And it's like it's done for you, and you're given a formula just to plug in the ABC and then just to get the answer. Okay, so without delaying anymore, shall we start this? So you have to, I think, write this first line. There are three different, these are algebraic methods. Okay, there are three different algebraic methods that can be used to solve a quadratic equation. Number one, by factorizing, and we will do a couple of examples. So please copy as I read. There are three different algebraic methods that can be used to solve a quadratic equation. And you please use different colors. You can use your whatever colors you have in any way you want. Now I have used colors for the topics and for certain words. If you feel like this part is important, you can highlight, make your note very colorful. That helps you to retain what you're writing. Okay, so number one is by factorizing. And this method works only if the quadratic expression in the equation is factorizable. You know this. You have seen this in your O levels. There are some quadratics where the quadratic equations where the quadratic cannot be factorized. We saw this already. Not all quadratics can be factorized. So if it can be factorized, you can just factorize. That would be the easiest way to solve. So can you quickly solve this first equation? You have? So I hope you're writing with me. X squared, I will show you how to solve this after you copy this. X squared minus 2x minus 24 is equal to 0 is what you have. Now I have given this equation already in the ready form. I could have jumbled up the terms and given you. Then you would have to prepare it into the, arrange it into this form. Now here I have already given it in that form. So can you factorize this? Has everyone copied this? Can I change the screen to the writing pad?
Yes, miss. For some time.
In some time?
Yes, miss.
Let me know when you are done, please. And I hope you can see that the word factorizable is red underlined on Word. This is a Word document. Maybe there is no such word, factorizable. I actually made this up. If you can factorize, factorizable. Oh, Senithu, you already found the answers too. Okay, can I change the screen now? I think so, right? So I'm going to change the screen to the writing pad. Okay, so that's the equation you have. So you have to think of two factors of minus 24. The number is minus 24. That gives you two factors of minus 24. That adds up to minus 2. So that is minus 6 and plus 4. So you can factorize this into x minus 6 and x plus 4. Okay. Now, I will ask you a question. I think we have discussed this before, but just to make sure, I will not bring this up again. So please pay attention. Who can tell me why are we able to say after this step, why is it that we say either x minus 6 has to be equal to 0 or x plus 4 has to be equal to 0? How do we say that? From this step, this follows logically. What's the reasoning behind that?
The above statement says x minus 6 into x plus 4 is equal to 0. So that means either of them has to be equal to 0. So we don't know which one. So we make it equal, make both the terms equal to 0.
Why either one of them has to be 0? Why?
Otherwise, we can, the result cannot be 0.
Okay, very good. Who was that?
Afra.
Afra. Very good, Afra. Yes, right? I have a product of two things here. This is a product of two things. Two things. Like A times B is equal to 0. If you have the multiplication of two numbers being equal to 0, you know that at least one of them has to be 0. It can't happen otherwise. Maybe both of them are 0, or at least one of them are 0. So this would happen if this is equal to 0 or that is equal to 0. That's the only way that this product could be 0. So you can build this argument because this is equal to 0. This is where that key thing is, because it's 0, right? Okay, so because I know that sometimes you forget the reasoning behind why we do this. With time you forget. And you do it like mechanically, like robotically, but make sure that you know why you do that. Right, so you get x equals 6 or x equals minus 4. Those are your two answers, right? Okay, so that's very easy. I will not spend time like that on solving a quadratic equation again by factorizing. You quickly do one more, or maybe I will skip this. This one, because you know this quite well. Okay, can you solve this? So actually this has to come. Solve. Example 2. You have x squared plus 7x equals 0. So this quadratic does not have all three terms, but you factorize. You can pull an x out. X squared plus 7x equals to 0. You can pull an x out. You can pull an x out. You get x plus 7. You have your two factors, x and that. So either this factor, which is just x, has to be 0, or the other factor has to be 0. That gives you another answer for x. X is minus 7. So these are the two answers. And if you just for a moment, if you want to connect what's going on in this solving the equation in relation to the function, corresponding function. If you think of the function corresponding to this expression, if you think of y equals x squared plus 7x function, you know that that graph is a smiling graph and it cuts the x-axis at 0 and oops, this must be 0 and minus 7. Oops, like that. Right? Now, all those connections you have to just have in your mind. Right? When you solve an equation, just quickly relate it to the corresponding graph. What I'm finding here is in the graph of this particular expression, where it cuts the x-axis. I mean, that's nice, right? So many connections that you can make. Okay, let's now, I think we will do one more where the factorizing is, this one. Example 3. x squared minus 49 is equal to 0. You can think of this in two ways. You can just move the 49 to the other side and square root both sides, or you can factorize this again. We are doing by factorizing, right? So if we actually, this can be factorized. This is a difference between two squares. This can be factorized as x plus 7, x minus 7, isn't it? And then you get x plus 7 is equal to 0, or x minus 7 is equal to 0, and you get x equals minus 7, or x is equal to 7. But more easily you could have done just by moving the 49 to the other side and then square rooting. Yes, Senithu is asking the sign between brackets is multiply. So to simplify it, you divide one bracket to take it to the other side, which makes, wait, okay, so we are going back. I'm sorry, Senithu, I'm just seeing your question now. Was it about example 1? No, it's about which example? X plus 6 is 0. We didn't have an x plus 6. Are you talking about the x minus 6? Okay. Now, Senithu has a good question. Now, let me write that again. Now, in the first example, in this example, I will keep it like that. You had this step, right? You had x, I'm writing this factorized step. X minus 6 times x plus 4 is equal to 0. We had this step, right? Senithu is asking, since this is times, can't we, so to simplify it, you divide one bracket. So can't we divide both sides by maybe say this one, this whole thing. So it'll look like this. I'm going to divide both sides by x plus 4. This, where is this coming from? Where is this coming from? It's coming from this, this knowledge that you have. If I have something like 2x is equal to 6, and I want to solve for x, you would divide both sides by 2, right? You would divide both sides by 2, because this is 2 times x. To isolate x, or to make x the subject, you would divide both sides by 2. And then I get x is equal to 3. Senithu's question is, can't we do the same thing here? Like, can't we just, I have this times this. Can't I just divide both sides by x plus 4? Here's what will happen. Let me write everything for you to clearly see. This is what he's asking. Can't I divide by this? And then Senithu thinks that won't we get, can't I just simplify that? Then I get x minus 6 is equal to 0 divided by anything is just 0. I get that. That's what he's asking. Can't we do that? What do others think about this? And then you get x is equal to 6.
But then means we don't get the other answer.
You don't get the other answer. Is that why we shouldn't do this? So what you mean is it's okay to do that, but the only thing is we don't get the other answer. Is that your explanation to this, or do you have anything else that you can comment on this, what we have done here? What we have done in this step, this particular, yes, someone is saying something?
Because it looks like only one factor is going to be equal to 0.
Okay, yeah, because one factor is getting cancelled off. So instead of dividing by x plus 4, somebody else could have divided by x minus 6. and then you would end up with the other answer. That's not the problem here. The problem here is not that, oh, then we get only one answer. That's not the problem. We have made a fundamental error, fundamental mistake that we can do in mathematics. Right in this step, right here, we have done a fundamental mistake, something that we should not do. We are not supposed to do. Who can tell me what that is?
0 cannot be divided by, it comes as 0.
0 cannot be divided by what?
Divided by another number.
No.
Because it will equal to 0.
No. 0 can be divided by any number. This is defined in mathematics. 0 divided by 5. 0 divided by 5 is 0. That is fine. There's nothing wrong in this. This is correct. 0 divided by 10 is 0. You can divide 0 by another non-zero number. 0 divided by the 31.4 is 0. They are all fine. I'll tell you what we are doing. What is the illegal thing that we are doing here? This x plus 4, what you can't do in math, you can't divide by 0. That is not defined. That is not something that makes any sense. Dividing by 0, dividing by 0. If you want, you can write this down in your note, like on the side in big red letters. This is something very important. Division by 0, division by 0. I'm not talking about 0 divided by something. Something divided by 0 is not allowed. You can't divide by 0. Division by 0 is not defined. I'm not going to talk about this a lot right now. If we have some time, if we can find some time, some other time, I will do that. This is not defined. And what is happening here is we are dividing by a 0, and we don't know that we are dividing by a 0. This x plus 4 is 0 when x is equal to minus 4. Without knowing, now this, you are dividing by something that is unknown. It has an unknown letter, unknown number in it, right? Here I was dividing by 2. There was no doubt there. Can this 2 ever become 0? No, there's nothing like that. 2 is 2. I'm dividing by 2. It's solid 2. But here you are dividing by a variable. X is a variable. X is an unknown. Then x plus 4 is unknown. I don't know whether, without knowing the value of x plus 4, I don't know whether for some value of x, don't know whether x plus 4 is 0, and I'm unknowingly dividing by a 0. You are dividing by a 0 there. Here. And you have cancelled this off. This is entirely wrong. You are doing 0 divided by 0 here. Because this x, when x is equal to minus 4, x plus 4 is equal to 0. So you are dividing by a 0 there. Okay, so just think of it like this. You do not divide by an unknown. If you know for sure that this unknown is not 0, it doesn't take the value 0, then you can divide. But if you are not sure, could this be 0 by any chance? You shouldn't divide by that then, because you might be dividing by a 0, and that will lead to errors. Okay, so hope that is clear. Let's go back to this. And I have this also. Can you just copy this as example 4 and leave space to do later, because this here to factorize this, it has a coefficient, the x squared term has a coefficient. You have to multiply it by the minus 12, and it takes some, you're welcome, Senitu. It takes a few steps. I know you can do it. It's just that this involves a couple of steps to factorize. Just copy that as example 4, leave a couple of lines to complete it. And then we'll go to the second method of solving a quadratic equation. So quickly copy this, 6x squared plus x minus 12. This is example 4, and this is to solve again. You have to write solve. I have not written solve. Okay, leave space for that. And let's go to the second method. Second method of solving a quadratic equation. Now, the first method doesn't apply to all quadratic equations because not every quadratic can be factorized. But the second method, completing the square, can be applied to solving any quadratic equation because any quadratic can be turned into the complete square form. Okay, so you write under that. This method works for any quadratic equation since all quadratic expressions can be written in complete square form. And let's work out this first example. Again, you should have the instruction, solve. Okay, I hope you have done copying. I'm going to change the screen. The one sentence you have to write here is, this method works for any quadratic equation since all quadratic expressions can be written in complete square form. Now our example is x squared minus 6x plus 2 is equal to 0. Now if you try to factorize this, you can see that it cannot be factorized. So you know that solving means to isolate x. The only problem why we can't directly isolate x is because we have an x square term and an x term. And you can't combine them to get one x term. They are unlike terms. That's the whole problem, right? That's why we had to do that factorizing method, because that gave us a different way of dealing with that. But if you just think of the normal thing that we do when we solve equations, solving equations is to find the value of x. So that means you have to isolate x. We have to make x the subject. And in normal equations, linear equations, you put all the x terms together and make one x term, and then you can isolate it. Here the problem is x is there in this term as a square, and x is there in this term as just x. And you can't put those together. But when you complete square, it combines these two and put x inside a bracket in one place. That's why completing square method helps you to solve this. So let's go ahead and complete the square for this. You know that complete the square is done only for these two terms, right? So what do I get? Square of what? X minus half of that number, that is 3. Then I have to minus 3 square, that is 9. Okay, so what I have highlighted here has become this now, plus 2 is equal to 0. Then I can simplify that as x minus, do you see now x just ended up being here? Originally we had x in 2 places, but when you completed the square, now x is just inside that bracket in one place. That's what makes us, enables us to isolate that x. I'm going to take the numbers to the other side. Minus 9 plus 2 is -7, and when I take it to the other side, +7. Now I can square root both sides. Square root both sides to get rid of that square. I'm trying to get to my x here. X is inside the square. So if I square root both sides, remember in an equation you have to do, you can do anything as long as you do to both sides. Senithu, nice. Senithu has gotten the answers for the example 4 that we left. Okay, so here the square root and the square gets kind of like cancelled off. You are undoing what has happened here. The squaring gets undone by the square root. So you get just x plus, I don't need the bracket. You get x minus 3 is equal to square root of 7. When we did surds, we learned that usually the square root symbol by definition returns only the positive square root. But here, since we are solving an equation, we have to write both possibilities. You get plus or minus root 7. Now, this is not a number that has a proper, it's not a perfect square. So it's a surd, right? Root 7. Positive root 7 or negative root 7. Now that gives us two answers. I can branch this into two branches. What I have here is x minus 3 is equal to positive root 7 or x minus 3 is equal to negative root 7. Right? Then I get an answer from each branch. X is equal to root 7 plus 3. That's one answer. Or x is equal to minus root 7 plus 3. Oops. Minus root 7 plus 3. Okay. Is that clear? Hope that is clear.
Yes, ma'am.
Okay. And you can see that our answers are not nice, proper, nice, round, like 3, 4, no, not integer answers. It's a surd. It's completely, this answer is irrational. Like this now, this particular, the corresponding function, if you think of y equals this expression, the function, it's a smiling parabola. It's a smiling parabola. And the two numbers here are this number and that number, whatever that number is, right? So this would be, I think 3 plus root 7, whatever that number is. You can approximately find from your calculator. It's going to be like 5 point something. Yeah, 5 point something. So this is 5 point something. Okay, and then this would be minus root 7 plus 3. That would be 1 point something, I think. Okay, so those are the two. These two places are those two numbers, right? Okay. Anyway, let's go back. Shall we do just one more maybe? Shall we do this one? Example 2. Because I have a coefficient for the x square term here. Again, you need to have the instruction solve. 2x squared plus 6x plus 5 is equal to 0. 2x squared, oops, 2x squared plus 6x. Thank you, Senithu, for the answers for the example 4. I will not